Good morning, everyone, and welcome. I'm Carrie Burke, your moderator for today's webinar, running a comprehensive application security program with Checkmarx and ThreadFix. You will have the opportunity to submit questions today today's presentation via the chat feature. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. I would now like to introduce Dan Cornell, a globally recognized application security expert who holds over 15 years of experience architecting, developing, and securing web-based software systems. As Chief Technology Officer and Principal at Denham Group, he leads the technology team to help Fortune 500 companies and government organizations integrate security throughout the development process. Presenting alongside Dan, we have Matt Rhodes, the Global Director of Application Security Strategy at Checkmarx. Matt has over 18 years of software development, sales engineering management, and consulting experience. During this time, Matt has helped some of the largest organizations in the world in a variety of industries, regions, and technical environments implement secure software development lifecycles utilizing static analysis.
Thanks, Carrie. And also, this is Dan, and I wanted to thank Matt for being with us here today. Checkmarx is one of the most popular integrations we have with ThreadFix, and I think that there's some really cool things that you can do using Checkmarx alongside ThreadFix. So, Matt, I'm thrilled to have you here today to talk with us.
Hi, Dan. Happy to be here.
Fantastic. Just brief notes about the agenda. We're going to talk a little bit about the state of application security and the mandate organizations have to implement application security programs. Then Matt's going to talk about the Checkmarx solution and how you fit Checkmarx into a comprehensive secure SDLC. Then I'll talk a little bit about ThreadFix and its capabilities and where we see ThreadFix fitting into the way organizations run their secure SDLC programs. And along the way, we'll also highlight some specific areas where using ThreadFix along with Checkmarx, using those technologies together, allows organizations to do some pretty cool things to help improve the security practices they have and to get better data about the programs they're running. Now I'll turn it over to Matt.
Oh, thanks, Dan. Happy everybody could join today. Again, my name is Matt Rhodes, and I'm a very long title. I'm more of a subject matter expert associated with secure software development lifecycles. And I'm going to just kind of introduce Checkmarx as a concept today, in addition to how it actually fits in the greater scheme of application security and a secure software development lifecycle. If we just advance the next slide. Oh, I guess I can do it myself. Thank you very much. So what actually matters in application security testing? And this is kind of a concept to introduce to the audience today. One of the biggest things I've witnessed in my career working with organizations looking at application security as an umbrella technology is that the concept of tool, the concept of scanning is really what's actually predominant in the industry. Customers, both existing and prospects, come to me and say, I want to talk about your tool. I want to talk about scanning my applications. Where I really like to level set and take it back a step. Static analysis, dynamic analysis, and all the technologies underneath the umbrella of application security, if they're viewed as a tool, they will be considered a tool by the stakeholders within your organization. It's not just about the scan, it's about defining a process. And the biggest thing that I bring to the table in discussing these type of concepts with customers and with different individuals in the industry is that it is a process. And I really like to say, I really like to help organizations transform their software development lifecycle into a secure software development lifecycle and really mapping out that process. Oh, one too far. Mapping out the process is really key in that you have different groups within your organization that have different marching orders. They have different job descriptions. You have the security side of the house that is interested in making sure that the organization's applications are secure, that you're doing all the proper testing from a static, a dynamic, and what other type of testing you're doing on the applications. But then you're actually working with the development staff. The development staff have a day job. Their main marching orders are to get the next release of software out, the next great feature function that's going to make the company a lot of money. And if you present static analysis, dynamic analysis as tools to the development side, from the security side, you're going to get some contention. And the last thing that you want in terms of an application security program is to kind of create an environment of contention between development and security. So that's where I really like to talk about a secure software development lifecycle and really identify what are the steps in the process and what are the technologies that you can use to help create that entire process. Because again, the last thing we want is, you know, the example of this slide here is the developer fighting with the security person. That's not productive for any organization. So this is where Checkmarx really, you know, defines a software development lifecycle, or transforms, excuse me, a software development lifecycle into a secure software development lifecycle. And as you can see, ThreadFix on the left side is a very important part of that process. You probably talk to many different vendors that have many different types of application security solutions. You know, the static analysis, the dynamic analysis, IaaS, RAS. What does that mean to you? Well, really defining the process from the lowest level, from the software engineers writing code all the way through to the build environment into production, and how do you correlate and quantify the information from this program? A lot of people say, you know, you see the SDLC, and, you know, people always mandate pushing security left in the SDLC, more towards the initial phase, the design phase. But without the appropriate process, you're really not going to be able to do that successfully. What I like to talk about on this slide, and I'm going to start in the upper left-hand corner, is integrating at the lowest level of your software development lifecycle, integrating into the developers' IDEs, allowing them access to scan their code often, and really work in a hand-in-hand relationship with security, so it's not like Big Brother over their shoulder coming in and saying your baby's ugly, which is their code, but really working with them to understand what the problems are in their code, how to actually remediate them in the best way, and to actually continue that process in an ongoing basis, because without a process that is repeatable, you're not going to basically stay ahead of the potential risks in your applications. The next phase, moving into the upper right-hand corner, is really integrating into your source code repositories. Again, this is a second step in the process, pulling code out on a scheduled basis from your source code repositories, making sure that as a application is moving through the SDLC, that it's actually having a check and balance to meet the security requirements of an organization, which is a key concept. A secure software development lifecycle, one of the major features of a secure software development lifecycle is knowing what you're being held accountable for. The biggest thing is, if an organization just says start dynamically scanning or statically scanning your applications, but they really don't know what their risk model is, what the things are that are most egregious to their applications in terms of risk, there's going to be confusion. So really defining a security policy for the organization based on the risk of your applications is paramount. It's very important because, again, without that, you're literally, you know, throwing darts at a dartboard in terms of mitigating risk. The bottom right-hand corner, talking about build, this is where, you know, if you have a very large development staff that are spread out geographically or segmented into different functionality of the code, at the build time, that's the first time that a lot of the time the code is brought together completely. So you can see the data flows from entry point of untrusted data all the way through to execution point. And this may be the first time that you actually are able to actually identify those data flows and come up with the best remediation cycle. So again, kind of to recap, we started off in the design, you know, development coding phase, allowing developers to proactively scan as they're writing code, as they're working on the next feature function, the next release of the software, having a check and balance type of situation where the security professionals pull code out of the source code repositories and do a check, a reality check on how are we doing with mapping to the security policy. And then the last phase is really mapping to when the application is built, when it's actually close to going into production, to do a last check and verify of the risk in the code. These processes, what I like to do when I work with my customers is I sit down and we draw your software development lifecycle on a whiteboard and then overlay check marks in terms of a static analysis solution on top of your existing processes. So it's not like a new concept that is being introduced and we have to totally rework our SDLC to allow for static analysis. I find that very helpful because it basically helps with roles, responsibilities, and what we need to do at what step of the SDLC. And then finally, looping in ThreadFix, which is a very important aspect, how do you correlate the data from many different technologies. Again, I work for Checkmarx, which is a static analysis solution for scanning the uncompiled source code, but you may have data feeds from dynamic or other type of security testing products. And, you know, we always want to approach with the way the industry is going in terms of M&A and big guys gobbling up smaller guys. Best of breed is in my opinion, is the best way for organizations to stay ahead of the curve. So if you have best of breed dynamic, best of breed static, best of breed whatever other technology you're looking at, you need a platform that is very flexible to take data feeds from the best of breed vendors that are providing application security solutions. And that's why we've partnered with ThreadFix, because we feel they have a great platform to solve that last piece of the equation. You know, working through the SDLC in terms of static analysis, but where do you put the results to compare them to dynamic or to any other type of data feed that would be constituted as application security? So this is a very kind of fluid slide. It's a little high level. I find that a lot of times when we sit down and do a solution architecture, which, you know, it's not really a charged activity, but it really opens the eyes of an organization to say, how does static analysis work best in my organization? Because not everybody develops software the same way, you know, and you may actually have different groups within your organization that develop software totally differently. So it's very, very helpful to actually sit down and visualize what a secure software development lifecycle looks like. And again, ThreadFix is a very important part of that process. Advancing the slide. So the bottom line is I'm not a big proponent of reading slides. I'm not a big PowerPoint person. I'm more conversational rather than presentational. But the software you sell or develop for your customers needs to be secure. And I've seen this really in my many years of dealing with secure software development life cycles and static analysis. People that develop software are now getting pushed by their customers for the kind of details of what they're doing to secure their applications. So when you actually have a repeatable process defined for a secure software development lifecycle, it not only helps mitigate risk, but it helps you show your customers that you're doing the right thing in terms of testing your applications for the next potential breach or hack that you're staying ahead of the curve on. So with that, I'm going to pass it back to Dan. Dan, hopefully that was what you were looking for today, and we can definitely, you know, kind of tag team any questions that come up at the very end of the conversation.
Perfect. Thank you, Matt. So you heard a little bit about Checkmarx and their static analysis engine. I want to talk now about ThreadFix. And a basic overview of what ThreadFix does is ThreadFix is a vulnerability resolution platform. And what it specifically allows you to do is to create a consolidated view of the applications in your portfolio and the vulnerabilities you've discovered in that portfolio. It then lets you prioritize your application risk decisions based on this data. And ultimately, it lets you translate these vulnerabilities over to developers in the tools they're already using. I think that's a great point that Matt made. If you look at security as a bolt-on or as something that runs entirely separate from your SDLC, you're going to have very much an uphill battle, and that creates challenges with developers. And so one of the things that we've looked at, you know, very much in line with what Matt was saying, is how do we take advantage of the workflows that are already in place? How do we take advantage of the investments the development teams have already made in their tooling and their processes in order to accomplish security goals? So that's something we'll be talking about more as we go forward. Just to kind of get a visualization of the flow of, you know, for ThreadFix, ThreadFix takes in the results of all the different testing activities that you have. So if you're running Checkmarx for static analysis testing, you can see those Checkmarx results alongside other testing activities that you're doing. If you're doing dynamic testing, if you're doing manual assessments, if you have third parties doing assessments, if you've got bug bounty programs, all of this data flows into ThreadFix, and ThreadFix normalizes and dedupes it. So that gives you a unified view of all these vulnerabilities. And then ThreadFix lets you take that data and put it out into other systems that other people are using in the format that they're going to need to see it in. So you can do reporting and metrics across your program as a whole, and also speak out to developers in the defect tracking systems, the IDEs they're using, you know, as well as package up application risk information and have that live in GRC systems alongside other risks that are being tracked in those systems. And so the idea is to allow the application security team running their application security program to make sense of all the crazy things that are going on in their environment, but then to be able to communicate effectively with other stakeholders, because that's how you ultimately get vulnerabilities resolved and reduce your risk. So looking at creating a consolidated view of your applications and vulnerabilities. ThreadFix lets you track your application portfolio. So you can lay out, here's all the different teams we have that are developing software in our organization, and here are all the applications each team is responsible for. And in doing that, that gives you a comprehensive picture of what is out there in your organization. Then ThreadFix lets you pull in the results of the different testing activities that you're doing. And so as you're rolling out Checkmarx as your static analysis engine, as you are getting different teams and their applications brought under a testing program using Checkmarx, you can connect ThreadFix to your Checkmarx server via an API account and pull over the data from this ongoing testing that's going on in your Checkmarx environment. And with the 2.4 release, we've actually made it even easier for Checkmarx users to get up and running in ThreadFix, where you can basically replicate the project environment that you have set up in Checkmarx. You can have that translated over into ThreadFix without having to do all of those, set up each of those individually. And so we've tried to make it really easy for folks using Checkmarx to quickly get value out of ThreadFix as well. Then what ThreadFix lets you do as you do this testing is to consolidate these vulnerabilities. And we allow you to do that across static, across dynamic, as well as manual testing, threat modeling, other activities that you're undertaking. And this is one of the things that we've gotten great feedback from, from a lot of the Checkmarx users that are also using ThreadFix, is they like to have the ability to coordinate or to correlate between the static testing that they're doing in Checkmarx and the dynamic testing that they're doing in other tools like a Burp Suite or Rapid7 App Spider. And so we've actually been working for the past probably close to 3 years at Dena Group, working with the U.S. Department of Homeland Security Science and Technology Directorate, developing a technology called hybrid analysis mapping. And what hybrid analysis mapping lets us do is to accomplish that correlation between static results and dynamic results. And the way that this works is the hybrid analysis mapping engine looks at the application source code, detects the language in the framework, and then builds an attack surface model for that application. So it essentially knows, here's all the dynamic URLs that will be exposed, and here's all the parameters that you can pass in that may change the behavior of this application. For each part of that attack surface, we keep track of the entry point in the application source code. So if you give us a result, for example, from a Rapid7 App Spider that says you have a reflected cross-site scripting vulnerability in the login.jsp page for the username parameter, we can query our database and find out, hey, this is a Java Spring application, this is in com.whatever.login.controller.java at line 42. Then we can look at our Checkmarx results, and if we've got a reflected cross-site scripting vulnerability that enters at that login.controller.java at line 42, we can link those two together and say, this is not two separate vulnerabilities. Instead, this is one vulnerability that we have multiple pieces of evidence about. And so we can combine the value of both the dynamic analysis and the static analysis being done by Checkmarx. Because you can see, here's the request that would be passed into the application. From Checkmarx, you can see here's the data or control flow passed through the application an attack would take. And then from the dynamic side, you can see here's the response that would come back. And so this provides your security analysts as well as developers a lot better information about this vulnerability, making it easier for them to run down and ultimately remediate. Once you've loaded in the results of all the different testing you're doing with Checkmarx and other activities, you can then look to prioritize these risk decisions based on this data. And so you can slice and dice the vulnerabilities and say, well, first, I want to look at things that were identified both by Checkmarx and by dynamic testing. Or, I want to look at my criticals, or I want to look at SQL injections first. So you can slice and dice this, go through and identify potential false positives. And in doing so, that lets you make an informed decision about which vulnerabilities you want to fix first. In every environment that we've worked in, people are always finding more vulnerabilities than realistically they're ever going to fix. And so identifying those critical vulnerabilities to fix, that is a very important part of the decisions that you make in running your application security program. Given those limited resources, you have to be able to allocate those resources as sensibly as possible. And having this consolidated view and being able to look at the results of testing that you're doing across different activities gives you that better data that you can use to start making decisions. In addition, something that we do with static results like checkmarks is we can look across applications that are being tested throughout the program and identify situations where vulnerabilities may be introduced by internally developed components. If you look at certain solutions out there will identify here's the usage of known bad open source components. Checkmarx is starting to incorporate this as well. What ThreadFix does is it applies that type of analysis but looks inside of your organization so that you can figure out here's a vulnerability that was identified in 15 different applications, but it's from internally developed code. Let's find the team that wrote this code originally, get them to fix the vulnerability and push this downstream, and then you fixed 15 vulnerabilities. And so, with ThreadFix's HotSpot technology, what we're trying to do is to look across the program and to identify opportunities that you might have in order to get some leverage out of the remediation efforts that you're making. As you repeat this process of doing testing, fixing vulnerabilities over time, that lets you start to gather really valuable reporting and metrics. And so you can see, here's what we're doing with checkmarks, but here's also what we're doing with our third-party testing program or with our dynamic testing program or our internal pen testing. And giving you that ability to look across all these different activities, again, helps you make better decisions as you want to allocate scarce resources going forward. And finally, we want to translate these vulnerabilities that are identified into the tools the developers are already using. This is one of the things that we've found, whether or not organizations are doing it with ThreadFix, but this is the big differentiator that we've found between app security programs that start to make progress and the ones that really struggle. And that is to take this vulnerability data that the security team cares about and turn those vulnerabilities into software defects, because that's what development teams care about. Again, going back to Mac's point, looking at, hey, let's map out the SDLC. Let's see what processes these development teams are already using. It's critical to be able to take this vulnerability data and to flow it into those processes so that these security vulnerabilities get fixed just like any other defects that are identified. Another great point Matt made, development teams, they have a day job, all right? And I think there's a lot of times a perception that developers don't care about security, but I actually don't agree with that. Most developers that I've worked with are very interested in security, but they have to care about security alongside any other number of concerns. They have to build features that were promised by a hotshot VP to an important customer. They've got to fix bugs that are degrading users' experiences that are not security related. They have to address performance issues. And so they care about security, but security is only one of those factors. And so to approach developers as security professionals and tell them, hey, this is a security issue and you need to treat it completely different than anything else, that's a message that's going to be really challenging for development teams to receive. But if you can understand the way the SDLC currently works, if you can understand the tools and the processes that the development teams have crafted over time, and if you can take advantage of those, that takes a lot of friction out of the remediation process. What you want to do is you want to make the security work of the security backlog live alongside all of the other work that these developers have to do. So if they have their sprint meetings or their scrums or whatever it might be, developers just get assigned vulnerabilities to be fixed in the same way that they would be assigned, building some sort of a new feature. And so that's something that's been very important for us, is to understand how does the SDLC work and how can we take advantage of what's there. Because at the end of the day, the development teams certainly will be judged to some degree on the security of their code, but they're first and probably most loudly going to be judged on, are they developing the features that they're required to on time and on budget. And so to the degree that security can take advantage of what's in place to minimize the impact of doing security tests, that's only going to increase the willingness of development teams to help the security folks accomplish their goals of reducing risk. Now we're going to open things up for questions. Again, if folks would like to use the Q&A feature, we will go ahead and send those in, and we will get those parceled out. First question here, what are the biggest challenges to SAST adoption, and how do you overcome them? Matt, do you want to take this one?
Sure, just get off of mute here. The question, is that the question in the Q&A section?
Yeah, the question is, what are the biggest challenges to SAST adoption, and how do you overcome them?
In my opinion, the biggest issue with SAST adoption is not defining that security policy up front, and really keeping it as a center of excellence type of technology within the application security team, and not looping in the development staff or the development management staff into the process. Because again, developers have a day job, they're very prideful of their work, and if security comes in and points at them and says their baby's ugly, which is their code, they're going to become defensive. They're not going to want to use the static analysis solution to help with finding the vulnerabilities, so they're going to become defensive and push back. Really having a clearly defined security policy of what are the things that we cannot live with in the code. And I see a lot of times that this can be based on industry standards such as OWASP or SANS or something like that, or it can be something based on a compliance concern such as PCI or HIPAA. But as long as something is clearly defined and communicated that these are the things that need to be remediated in our code, cannot go to production, and you help the development teams understand why the risk is there, it really helps with the adoption of static analysis. The biggest thing, again, is the concept of having security resident within the application security group, because, again, security is worried about the security of the applications, but in the end, it's the development staff that is responsible for actually remediating the issues. So hopefully that answers the question.
Excellent. Next question, how can a source code analysis solution integrate in a CI environment considering the time it takes to scan? Won't it slow down the whole process? I know that we're doing a lot of work, and I believe the Checkmarx folks have also done a lot of work looking at that. That's a big focus for us in our 2.5 release, is looking at ways to integrate security tools into the CI/CD pipeline. And I know just from working with different groups, one of the capabilities of Checkmarx that is really valuable for this, really interesting for this, is the ability to do those incremental scans. Would you like to talk a little bit more about that, Matt?
Sure, absolutely. And the biggest thing, too, is and taking it up a level, static analysis and scanning code is more about remediation than it is about creating, just reams of data that's never acted upon. So yes, you can do a check and balance and set thresholds within Checkmarx to alert you when something has changed. But if you're doing in a CI type of environment, builds every 10 minutes or builds every hour, there's probably not going to be enough time in the day to look at every scan result. So what I like to say is use the features functions within Checkmarx to kind of say, okay, if I see a 10% increase in critical vulnerabilities from scan A to scan B or C to D or something like that, make me aware of that. And then you can do a deeper dive. The architecture of Checkmarx is also very helpful in that it's a client-server environment where the scan is not resonant to the build server or the scan is not resonant to the developer's laptop where their IDE is installed. It's all performed on a centralized instance of a Checkmarx server and a Checkmarx engine, so the heavy lifting of the scan is done off of the resident machines of build and development. So I think that's critical because, again, you don't want to have a development staff that has a tight deadline twiddling their thumbs waiting for a scan to be done. It's much more effective when the heavy lifting is offloaded to a different physical or virtual machine. In addition to that, the use of incremental scan for debugging or for just looking at specific issues really saves a huge amount of time. We basically create a mapping of the code and only look at what that specific code change has affected in terms of the data flows of the application. So it's very helpful to actually work through the process, especially in a CI type of environment.
Excellent points. And looking at automating source code analysis to make it fit in DevSecOps, one of the things that we're looking at and the organizations that we're working with is some tasks are reasonable to complete inside of a standard CI/CD build, and so you want to, it's okay to wait for those before you move something through to the next stage of the pipeline. In other situations, if the task is going to take too long, then you need to get, you need to make sure that you get notified later on. And so really it's understanding, here's the type of testing or the type of scanning that I want to do, and do I want to wait for this, or do I want to, jump back into the process for some out-of-the-band thing later on? Again, and that's as you design the way that security is going to work in your, in your particular environment, those are the types of questions to ask. Let's see, we've got a question. How do we overcome application versions and their scans? How do we handle them? Matt, do you want to maybe talk a little bit about that in a Checkmarx environment?
Yeah, so I mean, with the concept of application versions, within Checkmarx, we account for that because we know that you have your production release and then you probably branch and basically start developing on the next release while the first release is still in production. And we basically have the functionality to branch an application. So if you started with application A and you have, you get to a point of time where you know a next release is coming out, you can actually branch to the next release within Checkmarx and have two parallel projects, one on the current development thread, one on the branched, and then you can actually merge those results back together at a different point if it's needed, or keep them as separate branches. So we really think about the way that people develop software and don't like to pigeonhole you into one process or change your process, so we can definitely account for application versions and branching within the development lifecycle.
Excellent. Yeah, and in the ThreadFix environment, we do support that in a similar way, in that you can, craft a container for results for your current production application, as well as create a separate container for testing you're doing on a different branch. And in ThreadFix, we give you the ability to tag applications. That's a common use for application tagging, to say this testing was done on an application in production. This testing has been done on the version of the application that is in a development cycle. And so really, it's just understanding, when you take a look at your process and understand the branching strategy that the development team is using, really that's kind of the first step, is to have that understanding, and then you can translate that into the way the different tools handle those situations. Let's see, question here, also from Matt. How does Checkmarx compare with HP Fortify?
That's an interesting concept. I'm very versed in, just a little background on myself on a little side note, I was actually one of the first employees with Fortify before HP purchased them. I joined the company in 2005, was with them for 10 years. We provide a little bit of a different platform and really work on the secure software development lifecycle, more so than what HP Fortify does today. A lot of the things that we bring to the table are feature, function, and process related, in that we have a client-server architecture, so we are very flexible and can map to the way you process or actually write your code in that software development lifecycle. We have some unique language support, such as Apex and Swift and Scala within our product that HP does not support, and we are still a best-of-breed solution. We have not been acquired by anybody. We are not watered down in terms of our thought leadership. The founder and CTO of our company that started the company in 2006 is still with us. So we really are a kind of the one unencumbered solution out there, and I deal with a lot of people that are tired of HP and Fortify on a day-to-day basis. I will never bash them directly because I spent a lot of my professional career for Fortify, but I think the best way to do is just take a look at Checkmarx. A lot of people open it up and say, wow, this is a very easy to use solution, and I can definitely see how we can integrate this in our SDLC, where Fortify is very cumbersome to integrate into the SDLC.
Very diplomatically stated, Matt. Excellent. Next question. How have orgs gone about static analysis triage? Did they accept the risk rating of the tool? In this particular individual's organization, they have SLAs tied to the risk rating, so they manually triage, and they're having trouble scaling that. That's an excellent question. We see a lot of challenges with that, and really it comes down to a question of the quantity of results that you're dealing with and where you want to allocate time. In a lot of cases, if you can get the tool set tuned up so that you feel confident in the quality of the results, in a case like that, you may just accept the risk rating that comes from the tool and say, we're gonna spend this time doing remediation rather than spending time doing adjudicating each vulnerability individually. We've seen that in certain environments where there's so many resources allocated to that triage and adjudication process, where if they'd allocated a comparable amount of effort to remediation, they could have fixed a much greater number of vulnerabilities. So that's something certainly to be aware of, is to look at those trade-offs between the time you're going to spend adjudicating results and the time that you might spend fixing. That said, again, you probably need to you need to understand how the tools are operating in your environment and have them tuned so that you have reasonably good confidence in the results that are coming out. Matt, I don't know if you have any thoughts on that.
Yeah, there's just a couple cliff notes here from the Checkmarx side of the house. There's two features and functions within the Checkmarx platform that are very helpful for this. The first is that the intellectual property behind Checkmarx, some static analysis solutions call them rules, some call them checkers. We call them CX queries. The CX queries, unlike all the other solutions in the market, are completely open to you. So when you're talking about triage, you're going through the results and looking at the results and do these fit our policy. What you can do is actually open up the Checkmarx queries that identify the risk and basically tailor them to your environment. There's no Wizard of Oz, man behind the curtain, secret sauce here. You can actually, in the UI, look at exactly how Checkmarx goes about finding every vulnerability report. So you can actually, minimize that triage and decision-making by really tuning the queries to your specific applications, which is really, I think, a fantastic concept and really helps organizations narrow down the vulnerabilities in terms of looking at the results. The other thing that Checkmarx brings to the table, or functionality that's a differentiator for Checkmarx, is we have a concept of a best fix location. So when you're talking triage, you may use a static scan result from a provider that has 100 cross-site scripting vulnerabilities, hypothetically, and each one is listed as a unique case within the scan results. The remediation process would have to be a unique remediation cycle for each vulnerability to go through, even though they may be very similar. We categorize 100 issues, and you can look at them individually, but you can also look at them through our graph view, or also commonly note our best fix location, to say that, I have 100 issues, but look, there's 10 inflection points in the code that all 100 of these data flows hit. If I apply my remediation there, my regex, my sanitization to clean out illegal characters, whatever you want to do, you can actually make 10 code fixes that will remediate all 100 issues. So when you're talking about triage, it saves developer time, resources, and cost by using the best fix location within Checkmarx.
Excellent. In the ThreadFix plugin for Checkmarx, does it have bidirectional communication? And if yes, is the update automatic from the Checkmarx database, or should we upload an XML? Great question. So the way that ThreadFix integrates with Checkmarx right now, it pulls data from Checkmarx, and so it allows you to pull the list of projects that you've opened in Checkmarx, and to pull either the most recent or all of the scans for those given projects into ThreadFix. And so, but ThreadFix right now isn't pushing any data back into Checkmarx, but you do set up the integration so that on a periodic basis, up to the discretion of the person implementing ThreadFix, you can say 4 times a day or every hour, I want to connect to Checkmarx and pull the latest data. Going forward, we're going to start adding some capabilities to talk from ThreadFix to Checkmarx, specifically in the area of orchestrating scans. In ThreadFix, we've given you the ability to orchestrate dynamic scans via ThreadFix for quite some time, and going forward, I believe in the 2.5 release, we're going to start giving you the ability to orchestrate static scans, for example, with the Checkmarx via ThreadFix. And so that lets you, as you're kind of designing your secure SDLC rollout, you can either, Checkmarx obviously exposes an API that allows you to do that and to orchestrate scans, and you can also, going forward in ThreadFix, potentially do that as well. And so you can upload Checkmarx XML files, but by far the preferable way and the most scalable way to create an integration between Checkmarx and ThreadFix is going to be to treat Checkmarx as what we call in ThreadFix a remote provider, which means you connect out to the server and pull the data over on an ongoing basis. That is, again, much easier to scale and to manage over time versus trying to juggle individual Checkmarx XML files. Next question, can I compare ThreadFix with the SonarQube dashboard? A great question. And so we actually, those are accomplishing two different things, and in the spirit we have with ThreadFix of getting vulnerability results into development tools, we actually have a plugin that lets you pipe data from ThreadFix into SonarQube. And so if, I see there being kind of typically two different users between ThreadFix and SonarQube. In ThreadFix, it's typically the application security team that is the primary user of the system, sometimes giving access to development team leads or security representatives if they need to reach into ThreadFix and look at data in more detail. SonarQube is typically used by development teams and development team managers to track their holistic backlog of work and technical debt that they've got. And so what we've done with the ThreadFix to SonarQube plugin is given you the ability to take all of this security technical debt that comes into ThreadFix, stuff that you've pulled in from Checkmarx, potentially stuff you've pulled in from dynamic scans, other tools, pen tests, so all of your security backlog. And then the plugin lets you put that security backlog into the SonarQube dashboard to be consumed by those development managers. And so, again, in answer to your question, I think it's, typically we see two different consumers, but in the spirit we have of saying, we know, ThreadFix knows all about application security, but let's translate that application security information into the tools that other teams are using to make security visible. That's how we use our SonarQube plugin. Next question is, does Checkmarx scan Clojure?
Yeah, this is Matt. Currently, we don't support Clojure.
Excellent. Let's see. Next question, if I have ThreadFix, do I have access to the attack surface mapping that is done? Yes, and I'll post in the show notes. We have a command line client that will basically dump out this attack surface to the command line tool. You can also dump that out to JSON. And we have plugins for Burp Suite and Zap, and I believe App Scan is either done or soon to be available, that lets you take that attack surface and feed it to those dynamic scanning engines, with the goal being to give them more comprehensive coverage so that you have reduced false negatives. And I've been doing presentations at various OAuth meetings, other venues, talking about that attack surface mapping. That technology also came out of the work we did with the U.S. Department of Homeland Security. And so in the show notes from this, I'll post some, I'll post links to that presentation as well as to where you can get access to that tool. I'm also working on some stuff, and we'll be giving presentations here in the coming months, looking at those attack surface calculations and watching how they change over time, and using those attack surface differences to trigger events such as to say, well, we've added this much attack surface, let's do manual testing, but let's focus our manual testing in these areas. And so we're playing around with some interesting things that let you use that technology that we've developed to help support other processes in addition to the static and the dynamic correlation. Next question, can ThreadFix handle pulling large data sets from Checkmarx? We have a project with over 75K issues reported. That shouldn't be a problem, and if you are having a problem with that, reach out to me and we can take a look at that. A challenge that we've found just as a developer of ThreadFix, or as the original developer of ThreadFix, now we have actual professionals that build it. But one of the challenges that we've had integrating with the different static analysis solutions is a lot of times the static analysis engines, especially for big applications, find very large information sets or result sets. And so, typically the pattern that we've used is we connect to find out this, connect once, give me a list of scans, and then for each scan, typically we'll ask for, give me the bundled result for all of those. So from an architecture standpoint, we shouldn't have a problem consuming large data sets. Again, you know, that's if you are having a problem, let us know, and we can take a look at that. How does ThreadFix compare to CodeDX? And so I know the CodeDX folks real well. They're also in the same program that we're in with the Department of Homeland Security folks. The way that I would characterize this is, like, I see ThreadFix as being a platform that you use to manage a large-scale application security program. And so it allows you to drive a lot of this automation, to take advantage of automation that's out there, to find new opportunities for automation, and to help you make sense of the data that is being generated by all these different activities across the entire organization. And so that's kind of how I view ThreadFix, is supporting folks that are trying to deal with these large number of applications, large number of results per application. And you know, the CodeDX folks, I think are, you know, they let you do more like tool running from inside of it, and so that's kind of how I perceive some of the stuff that they're doing. But again, I'd encourage you to take a look. Know those folks real well, like them a lot. Obviously, I prefer ThreadFix, but you know, again, there's a lot of people that are doing interesting stuff out there. Let's see. Next question. Will the community edition of ThreadFix be returning? Great question. And so, you know, ThreadFix has had a community edition, or the open source code, available on GitHub, as well as an enterprise edition. You know, right now, the vast majority of the development resources are going to the enterprise edition, just because we have to support our customers that are out there, and that's what's driving our ability to build, you know, to maintain and build the ThreadFix team. What we do need to get some fixes pushed out to the code that is in GitHub, and we have a couple of deals out there that are centering around the community edition that will drive some additional development there. But at the current time, the vast majority of the resources that we have are going to the enterprise edition. Let's see, next question. Let me just read this real quick. Static code scanning tends to be full of false positives, large amounts of findings, which can quickly frustrate dev teams when presented with massive reports of findings. These typically stem from a handful of sources or sinks that perhaps don't perform encoding or input validation. ThreadFix normalizes results, but it doesn't have the capability of identifying problematic sources and sinks, for example, with an XSS, to minimize the large amount of findings down to a handful of findings, and cannot identify trends. So in ThreadFix, we do a little bit of that, or we do some of that with the HotSpot technology that I talked about. But Matt, I think like you know, kind of the best place right now to identify stuff like that is typically in the static analysis engine. Matt, do you want to talk a little bit maybe about some of the visualization and the work that Checkmarx does to identify those types of kind of choke points in vulnerabilities across findings within an application?
Yeah, absolutely. So typically, a lot of the times, you know, when a static analysis solution, I'll start at a high level and work my way back. When a static analysis solution, there is risk in whatever we put into the application, into the scan result. You know, that risk may not fit your security profile. So the first thing to do, and one of the mistakes I see a lot of organizations do, is they start down the path with static analysis by turning everything on. I want to scan for everything. I want to turn on the biggest, broadest list of vulnerabilities. A lot of times you get pushback from a false positive perspective because, yes, there is risk in that, but it doesn't fit our security profile. So the first thing to look at to whittle down the scan result is to implement a policy that maps directly to the things you are concerned about. So you're going to immediately probably cut a lot of those vulnerabilities that you aren't really concerned about out of the scan result if you basically have a policy that maps to what you're scanning for with any static analysis solution. The second piece of the equation is, again, I mentioned this before, but Checkmarx CX query language is an open platform where you can actually see exactly how we find the vulnerabilities. So hypothetically, if you report a long list of cross-site scripting vulnerabilities, and you have a homegrown sanitization routine called CleanMe that is the regex that you have basically instituted for untrusted entry points that would map to a cross-site scripting vulnerability, you could add CleanMe to the list of known sanitizers within Checkmarx query language. So moving forward, if the data flow sees CleanMe, even though that's not an industry standard or something that's you know, commonly known as a vulnerability, you're going to have the scan results even more pointed to your security policy. So working with those two in conjunction, and for only the things you're concerned about, mapping to your security policy, and basically looking at the queries and adjusting them to your specific coding structures really focuses the attention of the static analysis solution checkmarks to find the things you are concerned about. The last piece is you may have a long list of vulnerabilities that are real. Maybe you have 1,000 vulnerabilities in cross-site scripting. I've seen more in my career. The best fix location, or the graph view, really allows you to visualize and see all the data flows for a specific category of vulnerability and say, listen, I have 1,000, but there may only be, you know, hypothetically, it looks like a tornado or an hourglass, that all 1,000 entry points hit one point in the code and then branch out to 1,000 execution points. So even though that sounds unwieldy and huge, we provided the functionality to visualize and see where the best place to fix the code is, and it's a one-to-many aspect where you can make a minimal amount of code fixes to remediate potentially 1,000 issues. So it's just about the process, again, with policy, understanding the intellectual property, finding the vulnerabilities, and then understanding the best fix in the best place in the code to provide the remediation. Those working in concert really help digest a large result set of vulnerabilities.
Very cool. Another question. Can findings, once normalized in ThreadFix, be automatically fed into bug tracking systems? Right now, that is a user interface supported process. So you basically click and say, I want to bundle these 7 cross-site scriptings together and make them into a defect. And that is also something that can be driven via the user interface. And so you have the ability to automate if you want to say, like, hey, after this scan, I want to grab I want to grab and bundle the results. I want to put all the like vulnerabilities together. I want to create a new bug for all the criticals or something like that. So you have the ability via the API to do that. In the upcoming release, we're going to allow you to set policies to say, if I run a scan and I find new vulnerabilities, I want to bundle them according to this logic and just automatically send them to the defect tracking system. There's good and bad in that approach. It's good in that you can support a tremendous amount of automation and you're notifying the development teams very quickly about new vulnerabilities so that you can get things fixed correspondingly very quickly. The danger there is if you're sorting out things like false positives, or if you need to do a better characterization for the developers, you may be creating tickets that are, they're going to be challenging for them to successfully deal with. And so as part of our, again, a lot of the continuous integration, continuous deployment security stuff that we're doing in 2.5, we're trying to support those types of automation so that you get that really tight integration. But from an implementation standpoint, really kind of what we've seen is you need to have the scan or scans of the application that you're performing pretty dialed in so that you've culled out the kind of initial set of any false positives that might be in there, and you've tuned the rules so that you have high confidence in the results coming out of each incremental scan. If you can get to that state with an application, which is not the most challenging thing to do, that's something you can certainly do, but it requires typically tuning for the application. But if you can get to that state, then there is tremendous value in being able to automatically push those things over. Next question. In an ideal world, we would have a SAST, DAST, and IS solution. Limited funds and resources, what would you recommend, in your professional opinion, to prioritize when picking a code scanning solution? From my standpoint, I guess my recommendation would be to figure out what's going to work in your environment and do a trial or proof of concept so that you feel comfortable about that. Certain organizations work very well with static analysis where the developers want to dig in and want those types of results. Other organizations need the proof, if you will, of a dynamic scanner where it shows here's the request and response. IAST is a fantastic technology. It supports, typically they're supporting like Java and .NET. So if that works for your application portfolio, then that can be very powerful. It's really something where you've got to look at your environment and understand both the capabilities of the technology type as well as the vendor of each technology, but also understand how you plan to implement the results, how you plan to evaluate and deal with the results in your particular SDLC. Matt, I don't know if you have any thoughts on that question.
No, I think you hit the nail on the head there. It's I really have nothing to add on that.
Excellent. Next question, are there any plans to support CA's Rally tool out of the box? Yes, that is of the defect tracking systems that we could communicate with but don't. Rally is the most frequently mentioned, and so that is something, I don't have a date for that, but that is certainly something that we hear quite a bit about. And in the meantime, ThreadFix exposes or has an extension API where you can write a Java class that basically implements 6 or 7 methods to do that support. Really for us, it's just on the product management side for ThreadFix, there's been a lot of interest in Rally. I don't know that there's been purchase dollars attached to Rally, which candidly is the fastest way to get something to the head of the pipeline. And so, yeah, Rally is something that we're looking at. If that's something you're specifically interested in, please reach out and complain to a biz dev person, and they will turn around and certainly make your wishes known. But yeah, Rally support not there yet, can be implemented via the extension APIs, and that is probably top of the list of the next lifecycle management tools that will be that'll be supported. All right, I think we've here we go. Next question, when does 8.2 come out? Because ThreadFix is at 2.4, I suspect that is a question for Matt.
That is coming out in, I believe, about a month. Don't hold me to that, but the last communication I had is coming out in about a month.
Fantastic. All right, I think we have managed to, if there's any other questions, please get them in either via the chat or the Q&A. But otherwise, I think we have managed to filibuster everyone here, and have hopefully, oh, here we go. No, just thanks. Well, perfect. Okay, well, thanks so much, Matt, and the Checkmarx folks for helping us out with this today. I think a lot of great information, a lot of great questions and answers. So that's always where the real fun stuff is. Matt, I don't know if you have any closing thoughts.
No, just appreciate everybody joining today. I thought the questions were fantastic.
Great. Well, again, thanks to everybody who attended. Really appreciated it. And we will be getting the recording of this cleaned up and put online here before too much longer, as well as getting a blog post up with some show notes, kind of responding to different, some follow-on links and questions that came up along the way. And look forward to talking to people going forward. Thanks a bunch.
Thank you.